Alright, so here we go with lesson 5.7. This will be the last lesson of chapter 5. And in 5.6, we learn how to graph one inequality and shade above or below to represent the possible solutions. Well, now we're going to be solving a system of inequalities. And anytime we hear the word system, we should be thinking two. So earlier in the chapter, we learned how to solve a system of equations by graphing. And what we were doing is we were seeing where the lines intersected, and it showed one point that the lines had in common. Well, now we're going to be solving a system of inequalities. So much like in 5.6, when we graphed a line and we shaded above or below, we're going to do the same thing, but we're going to do it with two different lines on the same graph. And so anytime we want to talk about system of inequalities, it's when there are two linear inequalities in the same problem. And so in order to determine the solution is going to be the shaded area that is included in the solutions of both graphs, or excuse me, both inequalities. And so how we're going to accomplish that? Well, we're going to do a lot of the same things that we did in lesson 5.6. We're going to graph and shade each inequality separately. She'll graph one inequality, shade above or below, graph the second inequality, shade above or below, and then what we're looking for is the solution of the shaded area that happens twice. Another word you'll hear me say is, where do the shadings overlap? So what area of the graph do the shadings have in common? And so if we just pick a couple of basic inequalities, I'm going to say y is greater than or equal to 3, and we'll also do x is less than or equal to negative 2. So I'm going to graph these really quickly. And let me mark my graph so we kind of have an idea of where we're putting the y-intercepts. So that's enough to get us started. If I'm at y is greater than or equal to 3, that means I'm going up to the y-intercept of 3. It's greater than or equal to, so I know it's a solid line. And then because of that greater than part, I would shade everything that is above. So that's the first inequality. Well, now I have to graph the second inequality. X is less than or equal to negative 2. That means I go to negative 2 on my x-axis. Again, because it's less than or equal to, that tells me it's going to be a solid line. And then where would the shading occur for this? Well, if it's less than or equal to negative 2, I'm going to go to the left of negative 2, and it's going to be all of this area. And if you remember from probably kindergarten, you learned that yellow and blue make green. And so when we're looking at the solution to this, I'm looking at where the yellow and the blue overlapped. So this green area right here is the solution to these two inequalities. Anything in this region is true for both this inequality and it's true for both this inequality. So anything in the green is greater than or equal to 3 for the y, but it's also less than or equal to negative 2 for the x. So we're going to be looking at the region where they overlap. Okay, so we're going to start with the first inequality. We're going to graph and shade y is less than or equal, or sorry, just less than x plus 2. And remember, we treat this as y equals x plus 2. Just a reminder of how it's similar to y equals mx plus b. And so what this tells me is I'm going to go to a y-intercept of 2. I have a slope of 1. There's a 1 in front of this x. That's up 1, right 1, up 1, right 1, up 1, right 1. And I keep going with that pattern. And then because it's less than, not less than or equal to, it's going to be a dashed line. So my line will roughly be like that. And then for my second equation, first I'm going to shade this. So if it's less than, remember I can test a point, I can test 0, 0. So is 0 less than 0 plus 2? Well, that would be 0 plus 2 and check. So the region of the graph that includes 0, 0 is what I'm going to shade. It's going to be everything below the line. So I'm going to go ahead and shade all of it. It's kind of a lot on this one, so that's okay. So there's that shading. Now I'm going to do my second equation, or second inequality. So y is greater than or equal to 2x minus 1. Remember, we treat that as y equals 2x minus 1 just for graphing purposes. That's going to give me a y-intercept at negative 1. So I go down here. This time my slope is 2, which means up 2, right 1, up 2, right 1, up 2, right 1. And I'm going to go down 2, left 1 just to get as many points as possible. And this one is greater than or equal to, so it's a solid line. And we're looking at that line right there. And now I'm going to also test 0, 0 again, because 0, 0 is not technically on the line, so it's okay that I test this point again. And this time is 0 greater than or equal to 2 times 0 minus 1. Let's work this out. 0 on the left. 2 times 0 is 0 minus 1. And is 0 greater than or equal to negative 1? Yes, it is. So now I'm shading everything where 0, 0 is compared to the solid line. So since 0, 0 is above the solid line, I'm shading everything that is above. And of course what you're going to see is where they overlap. So I'm only now looking for my solution where the yellow and the blue overlap. And so you're going to get this triangular section, this section right here. Anything in this green area, any point you were to select in that green area, is true for this inequality, and it's also true for this inequality. And so in this one, because I'm using yellow and blue, it automatically makes green. If you were only using pencil, then what you would want is shade the overlapping region dark or darker. So if I had shaded yellow with a pencil, I'd shade it kind of light, and then I'd shade my blue region also lightly. Then I'd go back to this area right here and shade it in much darker. So that way we would know which region is supposed to represent our solution. Alright, now we'll walk through some example problems that will get you ready for your assignment. And we start with answering the question, is the ordered pair that's provided in all four of these questions a solution to the inequality? Meaning that if we plug in the x and the y coordinate for both inequalities, does it make them both true? And if it only makes one of them true, then it's not a solution for both. It must work for both of them. So I start with 0, 0, and remember that the first number is our x, and the second number is our y. And so as I plug these in, I'm looking here. Well, in the first one, there's only a y. So I'm replacing 0 right here, and is 0 greater than 2? Well, already that doesn't work. That gets a family feud. And so I can say no, 0, 0 is not a solution because it didn't work for the first inequality. I don't even need to check it in the second one because it didn't work for the first. Okay, let's go to number 2. Now I'm at negative 1. And that's going to go here. And then I also have the 1, which is going to go in for the y there and there. So let's go ahead and test them. The first one, again, is just a y. So I put the 1 here. Is 1 less than 3? Yes, it is. Okay, let's check it for the second one. Is 1 greater than negative 1 minus 4? Well, that would be 1 is greater than negative 5, which again is a check. So this would be a yes. The point negative 1, 1 does make both inequalities true. So that would be a point on the graph that does work. It would be where the shaded regions overlap. All right, number 3. So now we're plugging in the y is 3 and the x is 2. So that's going there and there. The 3 is going to go there and there. So now we're doing 3 greater than or equal to 2 plus 4. And you look at that and you're like, 3 greater than or equal to 6? I don't think so. That doesn't work. I don't even need to do the second one. I already know that it doesn't solve the first inequality, so it can't solve the system. And then lastly, number 4, 0 is going to go there and there. And 4 is going to go there and there. Let's test them both out. 4 is less than or equal to negative 0 plus 4. That would be 4 is less than or equal to 4. So that one checks out. But we got to make sure it also works for the second one. So now I'm doing 4 greater than or equal to 5 times 0 minus 3. That's going to simplify to be 4 is greater than or equal to negative 3. And I believe that works. 4 is greater than or equal to negative 3. So check. So this would be in a situation where, yes, the ordered pair 0, 4 does solve the system of inequalities. It's one of the solutions for the system of inequalities. All right, so now we're going to move on to where we need to graph 2 different inequalities, shade them, and figure out where their shadings overlap. And so we start with the very first inequality. We have y is greater than negative 2. There's no slope there. That means it's a horizontal line. So we go down to where negative 2 is for our y-intercept. Because it's only greater than, not greater than or equal to, I know it's going to be a dashed line. And because it says y is greater than negative 2, I need to shade where all the y values are greater than negative 2 or above negative 2. So here would be how we shade that one. Okay, and now we go to the second one, and you see that we have the inequality y is less than or equal to 3x. Now remember, if you're thinking, well, where's the y-intercept? If it looks like it's not there, that just means it's at 0. So yes, it is in y equals mx plus b form. Our b just happens to be 0. So I'm going to go to 0, and then my slope is 3, so that means a rise of 3 and a run of 1, up 3, right 1. If I need to go the other direction, I go down 3, left 1. Because it's less than or equal to, I know it's going to be a solid line. Okay, and now what I need to figure out is, okay, where do I shade this one? Well, this one, 0, 0, I can't use as a test point because it is on the line. So what I'm going to do is I'm just going to choose this one right here. I can choose any point I want above or below the line. I'm just going to choose this one because it's an easy number to work with. So 1, 0. So if I test 1, 0, meaning x is 1 and y is 0, I'm asking myself, is 0 less than or equal to 3 times 1 plus 0? Well, that gives me 0 is less than or equal to 3, which obviously checks out. So I'm going to shade the region of the graph that does include 1, 0. And as I use my blue, I'm shading all of this right here. And of course, what you can see is the overlapping. And again, the reason why I use yellow and blue is because we can easily see where it makes green. So my answer, my solution to this question is all of this green shaded area right here. All right, I wanted to show you one that I completed in pencil. So y is less than 3. That means a y-intercept at 3, and that was a horizontal dashed line, and I shaded everything below it, and I shaded it very lightly. Then for x is less than 2, I went to 2, dashed line, and I shaded everything to the left of it lightly. But then where I saw they overlapped, I just darkened that in with a lot darker pencil. And that's how you would do it in pencil if you didn't have highlighters or pens available.